MPLS. And there we go. Then that's some ASP logo.
Revise our agenda.
I can't find this one. The young, the piece.
I think it's all one.
It's all one now?
Yeah.
One. For E and the rest of B.
T, RSVP, and
Okay.
yeah.
Perfect. And print that. Then correct it again. No. I got it together. Okay. Then
Do we have any slides for like? Do we have to move those? Right, well, let's put those on.
Yes, yeah. You do like the from first day and to yeah.
one. Now it's a problem.
Point. Is audio here?
Are we supposed to?
Oh, okay. So, good morning. The joint MPLS, TEAS, PCE, and CCAMP session is about to start. So we have a pretty packed agenda, so I think we should, it's on. Hi. Okay. Yeah, it's a bit, okay, so the session is about to start. Note well statement. So you should be aware that every contribution, submission, and so on you make here is a contribution to the IETF. And can you switch to the agenda? Oh, I don't know. Oh, that's, okay. Yeah, note well again. So no, let's go to this one here. So we have basically today is the second session. It's a joint session between MPLS, TEAS, PCE, and CCAMP. So we have a pretty packed agenda. I think about 17 drafts being presented and 7 presenters. We had a small agenda change. I hope Alia is here because she wanted to start. Ah, over there. Okay. And we moved, I think, from the last slotted draft up the queue because of flight scheduling. So what we do today is we mainly cover most of the young models, I think, we have in those 4 working groups, that you can get a nice overview about all the models. And yeah, I think that's mainly from my side. So I would like to start with YED.
So there's been a reasonable amount of discussion in NetMod around how to handle operational state and how this should reflect into the models. And I know there's concern and a little bit of confusion about how that's going to impact the 25+ models that we have in routing, which are moving along quite nicely. So, and which we want to actually, finish. So the first piece I want to tell you is I'm very sensitive to implementation trumps paper, okay? I care about the models that I need to hear about the models that are implemented. I'm not going to come and give you guidance of thrashing what's happening with operational state when you have code implemented. So these are guidelines. These are not musts. And we're still talking about the shoulds. I expect to send out, hopefully today, but certainly by next week, much more detailed wording. We're still thrashing on wording. So, basic idea. In the past, the old train has been take all of your operational state and stick it in a separate tree at the top level. And that is no longer the recommendation, which doesn't mean that if that's what your model is doing today and it's implemented, it has to change. It just means we really don't think that's the right way going forward. So if you can change, that would be lovely. Second, there's two sort of targets we can aim at if you think about this as a release trains. One release train is what I'll refer to as train 2. This is the shiny golden future, which we've been promised, with derived state. Sorry, with revised data stores. Sorry, it's Friday. With revised data stores. And the beautiful thing about the revised data stores is you'll have different views in, and you'll be able to take a look at the same model and pull out what was configured versus what is the actual operational state that's being returned. And it looks like a really nice technical solution. The only problem is we don't have it 2 months ago. In fact, they're going to have it in a couple months for the basics, and then the protocol work in NetConf and RESTConf is going to take another 9 or 10 months. And then we have to have implementations of it. I'm absolutely not willing to take a year hit for you all to actually implement these things that you've been working on really hard. That's not acceptable. But that's train 2. And so if you have a model that does not care about the difference between operational state and configuration state, that there's very little impact there, absolutely jump on train 2. Or if you know that your collaborations and brainstorming on which leaves to put in and all of those actual details for what we're modeling is going to take a year or so. It's going to take a long time. Or you have great enthusiasm, which I would deeply appreciate, for implementing revised data store, because we do think that's the right way to go for it. So there are cases where it totally makes sense to get onto train 2 now, and that is the ultimate direction that we see. In the meantime, for train 1, we want the ability for you to take your models and implement them and have them structured in a way that will be easier to do and make more sense with revised data store without having to go and thrash them again. So what you can do for train 1 is, instead of having a top level state container, you can sprinkle your state containers gleefully throughout the model where you think it will make sense to pull information out and use containers. That's the plan. I do expect to have much more detailed wording and guidance. We have, of course, been cheerfully talking about it. You know how that goes. So what I'd like to hear is your reactions and concerns and thoughts so that I make sure we send out the detailed text guidance, that it is considering the viewpoints of you folks who are working on and implementing this stuff. Thank you.
Hi, Tarek, Saad from Cisco.
I can't hear you with it on.
Hi. So my name is Tarek, and my question is the train 1 that you're proposing. So some of us folks here have adopted the OC model approach with config container and then state container. Are you suggesting we get rid of the config container and keep the state container in train 1 approach?
Thank you for nailing down to one of the fascinating details that we're trying to iron out fully in the guidelines. We're currently in, well, you know, I'm capable of having at least 3 opinions, and when we pull in 10 people, we're capable of having well more than that. So I don't have a solid answer for you yet. I think if you want to have a config container and a state container like OpenConfig does, for now, that is okay. I think I am hearing technical reasons both directions, and we need to make a firm call on it. One of the intents was that by having the containers, one could in the future deprecate them and not have too much impact. I suspect that Phil and Lou, who are lurking peacefully by the mic, might have additional detailed thoughts.
Lou Berger. So I think we're going to get into a nice conversation just sitting right here. I think you're right about this is a developing thing. There are differences of opinions that are being developed here and are being discussed, and certainly it would be nice if we had an option that minimized disruption to the ongoing work.
Yeah. The biggest message is, I'm not telling you this is how it must be. We need experience with implementation. We need to have it. There are some trade-offs. What the guidelines will be is, this is what we think would be a good idea, which is not you must or you should.
Lou Berger. Thank you for that clarification. That sounds really great.
Dhruv from Huawei. I have one question that once the revised data store is ready, and if we are on the old train, then we have to write a new model 1 year later down and change things. Is that correct? Is my interpretation correct? What happens once the revised data store is ready and the model is already published?
So 2 pieces of answer. One is that we can deprecate the dash state. 2 is that we are having some discussions about republishing some of the models. What I would recommend is that if you're doing a Yang model that is based on a existing published RFC that has the dash state, one approach you can take is to just augment the normal tree and not augment the dash state tree, but have the state there. I know that's not ideal, and their NetMod folks are talking about revving things like the routing config model, but we need to keep moving in parallel, and this gives us a path forward in parallel that lets us get implementation and deployment experience.
So just so that I can I get that, we do have to publish things again if we are on the old train. Like, once the revised data store is ready, and right now, if I am at the PC and PSEP state and I continue to do that, it gets published. But once the revised data store happens, because we do need to write a new model at that time.
Yes, I believe that we will want to republish those, which is unfortunate, but there are downsides to duplicating the state and having enough context in the tree. So I think that, well, I think that we really don't like that approach, but it will take time, and I think it's more important to get some models done. My understanding is that that if the model isn't implemented fully, if you don't have real good implementations of it, then it's only a few days to refactor the model. Where this starts getting painful is when we have implementations that are deployed, but if we have too many models on the old train, then it becomes highly unfortunate operationally because it's much harder to pull the state out, right?
Okay, thank you.
So I think we owe the community crisp guidelines on what is likely outcomes or will be the outcomes, because this feels a whole lot like when I've been on projects and they said, this rumor comes around, it may get canceled, and a lot of people get really demotivated and work really slows down. So
I
gotta make people believe that if they're pushing something to a goal line, that they should keep pushing, or if the goal line has changed, tell them where it is.
Yes, I absolutely agree with you, George. This was a decision that was made in NetMod this week, and I believed that we had managed to pull together crisp guidance as of last night, but I am, it is better to make sure that the guidance we give out is correct because changing it is worse. But the short form is, don't be demotivated. What I care about is the fact that you're doing these things and getting them implemented. And implementing something is going to trump any aesthetic decisions about where you put your state.
Yes, that's nice, but there are many people doing independent implementations, that could get a little messy if we're not careful.
I understand that. Unfortunately, without being able to add 8 hours into last night, yes, I hear you. I'm trying to get the guidance out today. I'm willing to stall a day or two in order to have it be correct. But what I've told you is we don't really like having the dash state at the top level. We think we're going to be that's going to need to be going away and deprecated. That might be a year or so out.
I always thought we should do it the way Model 2 is. So.
Yes, so did. We're delighted that the technology needed to do so in revised data store is moving along so smoothly.
So we're going to go to a comment over here, and then we'll cut the line after Luke.
Penlong Jiang, I wonder, is this recommendation only targeted at the routing area or targeted at all the other areas? For example, the OPS or internet area? I think they also have a lot of young modules.
Lou Berger, I actually can take that because I was going to stand up as NetMod co-chair and make a comment. And I think, so what I heard you ask, excuse me, what I heard you ask is the direction that's coming out just for the routing area, or does it cover everyone?
Yeah.
So what we're trying to do in NetMod is come up with guidance that minimizes pain for both now and when we get the eventual solution. It's an optimization function, so we're trying to balance and figure out what the optimization point is. So there's trade-offs. We're trying to figure out which one's best. In NetMod, we're going to take the guidance, put it into the working group, put it into a working group document, and then eventually we believe that should be the guidance for all Yang models. But that's going to be subject to normal IETF process and working group review. That's all we can do as chairs. Now, what happens in the routing area, and that's your
right.
choice.
So what will be maybe the difference is nuances in terms of should or such. We're trying to be aligned with what NetMod is doing, but my focus is making sure that all of the hard work, because I know it's been hard and it's a lot, that you have been doing over the last few years doesn't get thrashed. That what we focus on is getting them implemented and done. And so I will be certain that we will not be sending models back that have that are not conformant to the most recent recommendation, because we'll grandfather things that are implemented.
And the comment you made before about implementation, we think is really important. And we're trying to be very sensitive to folks that have been implementing along to what's been progressing, and trying to minimize the pain for that while taking into consideration that some models haven't been implemented at all, and being more willing to make changes on those.
Another piece of it is I can set guidance for what is required in routing. Obviously, we collaborate gleefully across all of the IETF. So I don't think we're going to be radically different, but some of the emphasis may be different, and certainly the timing is going to be different. And that's the issue.
And the timing is one of my big concerns, because this is an optimization problem, but if the longer it takes you to find the optimal point, it's going to be a bad thing. So my comment is, in this situation, the perfect is probably the enemy of the good.
You will notice the existence of train one and an emphasis on let's do train one so we can get moving.
Okay, I think that the train's about to fall off the rails, so we're going to have to.
That's the statement I wanted to hear you say. Okay.
Right. We'll have to stop there.
Okay. Thank you very much, and thank you for the time.
Okay, thanks, Aaliyah. The next speaker is either Jonas or Amy.
Hi everyone, I'm Amy from Huawei. I'm going to present about a draft, a young draft, which is for a quite special device. I think for here in IETF, it's for microwave and millimeter. So, overview. The key point is that we have another companion draft which is for framework, and so in the young draft we follow the requirements and the how to satisfy the use case from the framework. Another point is that this young draft is argument based on RFC 7223, and we take two inputs. One is from there's individual draft about radio link, and then another input is from the ONF microwave information model. So update from 0.0 version. First, we have a new co-author from NEC. Then the technical change is that in 0.0 version, we just finished the young definition for carrier termination configuration. And in this latest version, we have complete all the necessary parts in the young model, which includes, for example, carrier termination configuration states, and also radio link termination, and also some related with MIMO XPIC, and also something related with protection. And another key point is that we have an article in the latest IETF journal to have a brief introduction on the status of this work. So this slide gives an example about how to use the model. And the left part shows from a load view, which indicates that if you have an Ethernet interface, which is transported over the microwave link, and how should the model this function. And then we will see there will be several layers that will be Ethernet and radio link termination, and also carrier termination, and which each corresponding with its names, and what is the lower layer for its current layer. And you will see also the states for each layer. And when we're developing the model, we received some comments about what's the difference from the ONF information model. So we would like to hear to clarify a little bit. And what ONF defined as an information model, while what in our current draft we are defining a young data model. So I think basically the difference is between what's the difference between the information model and the data model. So we take reference from the two existing RFC. One is 3443. Screen very clearly. Excuse me. So basically, the key idea is that information model is defined as managed objects in a very conceptual way, while data model provides more implementation details. And there's another key finding is that you could consider in that data model as a rendering from the information model. And during the developing the young model, we also take the ONF information model as an input. This is a very important information. There's some discussion. We received a good comment from the listener from Nokia about this draft. There's very technical details, for example, maybe to add some capabilities and have some more clarification on the current definition. And also we have a few other questions we would like to hear from the working group. For example, is it possible to define the alarm technology alarm in the draft? Because we noticed that there's in that mode there's a alarm management draft, and we are not quite sure if we could follow in that way and just add a few definitions for the technology-specific part. Another question is about the protection. And we've noticed that in GE model, there's a T-eternal draft. There's some definition about the protection. So we were looking into that and to see if the definition is good enough for our purpose. And so we will take into the further consideration. Another point is how to define the capability attributes. For example, if network elements is able to support function ABC, this should be reported to the controller or the network management systems. Or another way is that we just let the controller to configure what we would want, then the network elements just return the error message if it's not supported. So we will continue discussing on these open questions. So the next steps, we will resolve the comments. While we are resolving the comments, we would like to ask the working group adoption. And currently we have a joint effort. We have a design team to work on that, and it's not a very big group, but I think it's a key message that attracts many interest from the different parties. And the site discussion is we have a lot of site discussion in this week. That it's end of the week now, so it's all done. Okay, that's my presentation.
Yeah, thank you. So next is East Young Pass computation. Who's going to present that?
Okay, thank you. I'm Italo Busi from Huawei, and I'm presenting on behalf of the co-authors of the draft. So what we did, we presented this draft to IETF ago in CCamp, and we moved it to TIS in the last IETF to make it more generically applicable to traffic engineering. And we have done some changes since the last IETF meeting. We have had some detailed analysis about how big can be the detailed connectivity matrix in the topology model, to see whether it is possible to live in a real network without path computation. We have added a new chapter to describe the possibility to have with only one RPC request get multiple LSP, the path for multiple LSP. We have added some security considerations, and we have introduced a YAM model for the stateless RPC. So for the detailed connectivity matrix dimensioning, we have many factors that we need to take into account when we have to provide all the possible paths across a network which is abstracted by an abstract node. So we need to have as many entries as a full mesh of the endpoints. For all the different bandwidth values that people can ask path for, you need to, the path can be different. The path can be different for the different H matrices that have been defined up to so far, and also for the different bounds and priority. And we can ask path with local protection or without local protection, or we have administrative color, which are also an attribute, and SLG. All these factors multiplies together and gives can give a huge number. We made an example for an IP network, assuming only 6 priorities matrix and 20 bounds. We get around 304, only 4 endpoints, which is quite small. We got 300,000 paths, which with some assumption means 300 megabytes of information just for the connectivity metrics, and assuming that when you create a new LSP, 20% of these paths needs to be changed because the optimal path has changed. Somebody has used the bandwidth for the optimal path. It means that every domain controller needs to report around something 60 megabytes for refreshing the status of the detailed connectivity metrics. So the conclusion we think is that using only the detailed connectivity metrics is a little bit a some scalability problem and is applicable only in a few cases, small network, and if we constrain the possible metric, the possible root computation constraints that you can request. So the idea is that part computation RPC can help in resolving this problem. So you don't have to provide a complete detailed connectivity metrics, but only what you think is useful, and then use the part computation where you don't have the information that you need. For the part computation of multiple LSP, the basic idea is that we want to have to get more paths by reducing the number of part computation requests to speed up the operations. So, for example, if you want to calculate the optimal path for a multi-domain path, we have multiple and we have different ingress-egress points from a domain. We have many possible paths we have to request. So if you request a path from every single ingress and egress points, we have to, for example, in the intermediate domain, to send 9 requests to get 9 paths. We have the idea is that it's much easier to send one RPC request and get all the 9 possible paths that we are interested on. So minimizing the interactions between the client and the server. That's the intention. So we have added some consideration about this possibility. We have added a YAM model. So we agreed, based on the past discussion, that for stateful part computation, we can use the T-tunnel in the pre-computing mode, which is already described in the D-tunnel model. But we have seen some value also having a stateless solution, and we have added a YAM model for the stateless solution. Of course, this YAM model is in full alignment with the T-tunnel model. We are importing and using the groupings from the T-tunnel model. And we have got some questions and comments, and we are working in close cooperation with the T-tunnel model authors, Tarek, Shuteng, and Igor. And thank you for their help in resolving the open issues which are common, in our opinion, between the T-tunnel and the part computation RPC, and we are still continuing on doing that. We are working with GitHub. We have a GitHub area where we track all the changes to the RPC and where we track all the open issues and discussions. So you can just go on this GitHub and see all the issues and where we are. We have some open issues. I will go quite a bit quick on that because we have many of them are really related to the T-tunnel and are going, and we are discussing how to resolve it. The first major open issue is about what to do. As we have said, using only the detailed connectivity metrics seems not scalable, but also using only part computation RPC, if you have many domains, is also a big deal. It's not easy to, we have a scalability problem if we have to send a part computation request to too many domains if you want to do a part computation multi-domain. So the idea that we have is that we should use we should combine the detailed connectivity matrix, so the topology information, together with the part computation to have the optimal way to perform part computation over such a big multi-domain network. There are different ideas discussed about how to do that, but the question we have is, does it really matter for us in the IETF to describe the optimal way to use our tools, or is just enough for us to describe the tools and let to the implementation figure it out? So we do need to provide the standard tools, and the implementation should just get and understand a different implementation can use the different tools in a different way. Everybody can do what they think is the best way to solve the problem. So that's one of the key questions we are having. Otherwise, we explode in the discussion to try to standardize the best optimal solution rather than standardizing the tools that we need. And then we have some detailed discussion. We have some, for example, one proposal is to have a residual bandwidth as a new metric. Is an idea that came up during the discussion, and most likely is going to be submitted also to PC working group, because it's something which is missing in PC and in our model. And the idea there is exactly the same: reduce the number of requests that you can send from the client to the server. So if you know what is the residual bandwidth from your part, you know that maybe that part is still the optimal part for the next request with the bandwidth to the residual bandwidth. We have some discussion about whether we need, when we request a part computation, to constrain. If you have multiple topologies, we want to be able to request and say, okay, calculate the optimal path across a subset of the available topologies. So include or exclude the topology. It's still in discussion whether we need it. And we noticed that the local protection is missing, so we would like to add it. There is some discussion also in the context of the tunnel about the delay metric or all the metric in RSC 5440. We are discussing about how to add them to the T-tunnel model and to get them in our RPC. We think it will be also useful to, when we request part computation, to indicate whether the constraints is optional or mandatory. It's still something we have to add. We are discussing on that with the T-tunnel models, authors, because we know this is available on PC and we think it's also useful to have it in Yang. We have a set of clarifications which are under discussion again with the T-tunnel model. We have some questions. We are not sure how to use the model to do how to use the model, and we are working on that. And the capacity unit, how to describe the bandwidth capacity, we would like to align with the changes that have been done in the T topology and hopefully in the T-tunnel to describe the capacity, because the capacity expression is different technology by technology. And we got that's a young question. We have a grouping in the T-tunnel model, the tunnel params config grouping, which contains attributes that we need. So we want to reuse in the part computation RPC, and attributes that we don't need and we don't want to reuse in our part computation RPC. We are not sure whether we can have in the Yang, we can say use this grouping, but not use this set of attributes, or we need to ask the T-tunnel model to split the grouping in two groups. So yep, thank you, correct.
Tarek from Cisco. You mentioned constraints. Some constraints might need to be mandatory versus optional.
Yeah.
That violates, for example, unconstrained LSPs. Like if you want an unconstrained LSP,
well,
I think.
Unconstrained, I guess you don't specify any constraints.
Right. So you cannot say this is mandatory then, right?
Yeah, but I want to say, please set up an LSP with, if you can, please keep the delay minimum to 100 milliseconds. And if you cannot, please set up the LSP, do your best in doing that.
Okay. So there is a misunderstanding about, mandatory as... as
mandatory means if you're not able to set up the LSP, which my bound, don't set it up.
But not Yang, Yang kind of mandatory.
No. It's mandatory in sense of the part computation must satisfy these part constraints.
A best effort versus hard.
Exactly. Soft versus hard constraint. Yes.
Okay.
Maybe we could call it a relaxation of the constraint, something like that.
Can you repeat? Call it
relaxation of the constraint.
Okay. Yeah.
Okay. Thanks.
Thank you.
All right, it's good. If I understood the draft well, it's kind of relying on the fact that you took some one-pass request by another, so sequencing it. So how do you think that proposal would work if you say you need 10 pass from a single source point to 10 different destinations? Would you need to sequence them, or can you run them in parallel?
So you mean here, whether you need the requesting multiple RPC is instead of one after the other, you say I can send 10 requests in parallel.
Yeah, which not necessarily need to end up at the same point. It's just, let's say, on that kind of topology.
Yeah. So the same client can send 10 requests to the same server for different LSP instead of one request. Okay. I don't know. I don't know the answer. I don't know. I can ask. I don't know if I think young experts has an answer to this question. If you can have 10 RPCs requested at the same time. Oh, Michael.
So this is Michael speaking. I see no particular reason why you can't do it. There might be overhead if you do it, for example, over a netconf, because then you need multiple netconf sessions. If you do it over RESTconf, it just implies a couple of different HTTP transactions, which is pretty lightweight. So I think from a protocol perspective, this is not an issue. It obviously depends a little bit how your PC logic internally works. There could be issues there, but from a protocol and Yang perspective, nothing prevents that.
Okay, so maybe we need to add some more detail. We need to analyze more in detail.
Yeah, just to comment on, I didn't assume that there is any issue on Yang because, well, it's just a sentence session. I was wondering about the calculation mechanism because you basically need to rely on the feedback from the network on the free resources. So when you request one, you get free resources, you select one. But if you request 10 times in parallel, what you get back is you don't know. So it's more about the internal thing rather than the amount of requests.
So I think
your concern is about the order. If you send them in parallel, the order at which the 10 computation requests are actually executed by the server as an order that you don't control. While if you go
when you request, so for example, if you do your request here, you get from the server a list, let's say, of free paths.
Yeah.
But if you would do in parallel another request, that would theoretically assume that the same free paths are available. Then it might be that the first one is not served, but the second one.
Yeah.
You need a lot of crankback.
Yes,
So,
that's the discussion we had last time about the stateful versus stateless. Yes, the problem is, yes, you cannot, in a distributed system, you cannot, with a stateful, you can get some notification. So if I ask you the part computation request, I give you, and then one commit, then the other is notified that is no longer available, and the best part is a new one. And you can do with stateful, but again, you still have some window because you have the notification has to come up. So,
but it still means that in effect you need to do it one by one and not, let's say, a batch.
I don't understand why the batch is making the things more complex.
So can we move that detailed discussion to the mailing list? So
yeah, what about one RPC packed with multiple requests?
Yeah.
So multiple requests don't have to be multiple RPCs.
Exactly, yeah. It's one RPC, multiple requests in one. Yeah, so minimize the interactions on the protocol side. Yeah. Okay, quickly on the next steps. So what we want to do is continue to work on the open issues, maintaining cooperation with the T-tunnel model authors. The YAM model is not complete on the multiple LSP, so we have to update it. We have added just a description of the capability, but not in the YANG. We have discussed after last IETF meeting the problem of the stateless RPC when the server takes too long time to reply and is starving the client. We forgot to add the solution to the draft. We will add it in the next version. And we will look for further comments and feedbacks. And thank you for the comments you raised today. Any other comments on the mailing list are very much appreciated. And we have discussed options for where to put this part computational RPC. And the current working assumption is to keep this RPC in our draft, but to change it to make it as an augmentation of the T-tunnel RPC. This will make the reason for that is that being in a different module, it will be easy for people who don't want to implement it to say that we don't implement part computation RPC because we don't support this module. So it's easy to track the fact that we don't support it. If you support it, there will be an augmentation of the T-tunnel, so people will see that under the T-tunnel string and not somewhere else in the YANG structure. And any change that we need to do on the RPC will be done in this draft without impacting the other document. And we think we see many open issues which are in common with the T-tunnel, so we think the document is almost ready to become working with the document. So we are open to suggestions from you. Thank you.
Okay, one more question, and then we move to the next presentation.
Yeah, hi. I don't have a question for the slide, but the question in general that within the working groups, have we concluded that we will have both models, that we will have stateful compute only, what's there in the tunnel model, which is a working group document, and then this is the stateless. So just for our understanding, has that consensus, can we say that we have a consensus in the group that they will be both the things that will be supported? So mostly the questions for the chairs. I think why my concern also was that we would like clarity. I'm okay with both. I think there is a use case for both of them. But from the architecture level, I was also wondering that if we do, for example, the stateful compute only, should we also think from the PCE architecture? If that use case works in Yang, does it work for PCEP also? That I may just want to track it, and then because we want to keep things aligned, we don't want to personally feel that some features are available only in Yang, but some are not there in our protocol. So if that alignment can be there across all our groups, it would be nice.
The question is for John, but I support it.
As a super, even with the T-tunnel model, I think it's also possible to make it stateless if you want.
Guys, are you having a discussion that we should all hear, or is it? Right. Yeah, I think from the PC working group's point of view, I don't think we've had that discussion, so I don't think it's possible to say whether we have consensus. I think whether it's a model that is, if it's a model that we want to adopt, if we want to adopt both models, it sounds more like an architecture question. So, I mean, it's probably a sensible thing to be asking in T's as well. But I think it's not possible for me to say at the moment whether we have consensus.
Can we agree on which mailing list will continue this discussion? I don't care what the answer is, but
yeah,
it's less MPLS than the T's and.
I think the right answer is to start with T's because it feels like an architecture level question.
Okay, so
maybe
people
Drew
want to discuss this on, put it on T's.
Drew, kick off the thread on T's.
Just understand the discussion will be about the need to have stateful and stateless back computation request interactions.
That's right. I think if we want both, then we should keep consistency.
Okay.
Yeah. Thank you. And thank you, Italo. Any other questions? I think we said one question, didn't we? So the next presenter is Xufeng. Yeah, you have 15 minutes.
Morning, this is Xufeng Liu, reporting the status of the model for the MLDP. So this model, we have a history since IETF92. So this is a history of that, and and the recent history of that, we split the model. Used to be one model contains both RDP and MLDP. So we got comments saying that it's too big. So we split that into RDP and MLDP. So since last IETF, we submitted the model, one model for RDP, which is presented on Tuesday. So here we're talking about MLDP. So the changes since last revision. The major work we did is to partition the features into base and extended two modules. So we have base and extended module. So the idea is that we have the base feature, cover the base MLDP feature, FC6388 into the base module, and also including some important features. All others optional will be put into the extended module. So here is the list how we partition the features. So let's see here we have P2MP and P2MP at the base, and we have some make before break as base, but some extended feature, hop and spoke will be put into the extended, and the IPv4 are in extended. So this is how we have done so far. Then the two modules, the base module, it's everything in the base module is mandatory. So the extended module is optional and also contains some features so that we can implementer can choose which feature to implement. And the augmentation relationship is that the base module IETF-MRDP augments the IETF routing, and the extended module augments the base module. Then the MRDP base module will depend on the IETF routing, and the RDP base module, and because we have done the same thing to the RDP, so we also have base RDP and extended RDP. The extended MRDP module will depend on MRDP base and also RDP extended. So here, this is high-level hierarchy we have. We have both RDP and MRDP put together. So the MRDP is depending on the RDP. So you have to have RDP to make MRDP work. The base module for the MRDP, here is how it looks like. So you see it's very simple. And the extended module, it's much longer, contains more features. So that's what we have got so far. Then we have some expanding items. So one thing will be aligned to the op state. So whatever we decided with the guideline, we will follow that. And we have some other internal issues. We're trying to fix some inconsistencies, and then pretty much that's what we plan to do. We move to the next. Okay, here's the status for the T topology model. All right, here's a summary of the changes since last IETF. We added the modeling for the supporting combination points. We added the support to specify some default attributes for connectivity metrics and local link connectivity entries. So we added the NSRG, so we allow configuration of the underlay tunnels. We provided the option to set underlay tunnel to be dedicated or shared, and we also improved the client layer adaptation for the case we have multiple layers, which in this case which are more than 2 layers, and we clarify some terminology here in our topology context, particularly here with the customized and abstract topologies. So I go through them quickly to have much time. So the supporting termination points indicate the modeling concept so that we can have the relationship between the abstract topology inside that app and the underlay topologies. So inside the abstract topology, we may have termination points, which is supported by either underlay topology or some supporting node. So here we will have this relationship modeled here. So the modeling changes will be adding a list of supporting termination points. Then for the connectivity matrix, we added a container here to hold the default matrix in case we don't have the attribute specified in a particular connectivity matrix entry. Same thing to the local link connectivity list entry. Then we also added the MSRG modeling. So this is opted to the SRG. So we mentioned the last time, and we did the implementation here. This is a modeling changes. And for the underlay tunnel configuration, now we can specify which tunnel to use for a particular abstract link. So you can pick existing tunnel now. And we can also specify this underlay tunnel will be shared with other link or dedicated to this particular link. For the multi-layer topology modeling, we now can support the topology with more than 2 layers. So in this case, we have a hybrid node which supports 3 layers. Then we can decompose them into orange layer, blue layer, and green layer, and we can do the transitional link between them. So this is one approach we use the decomposition and the transitional link. Another approach will be using the interlayer lock ID. So in this case, we don't need to do the decomposition, but we need to assign those IDs. We can also support with this approach for the 3-layer hybrid node. To achieve that, we also added a piece of information here to clarify which currently this hybrid node can support for one particular tunnel termination point. So this is some clarifications for the customized topology and abstract topology. They are related, but may or may not be the same thing. So we have clarification here. Then the next step will be we need to align to the whatever the base model from I2RS. The I2RS topology model changes. So some background for that model. The I2RS base topology model went through last call and but was sent back because of some issues with this server provided belief. So after many discussions, the end result as of I think Wednesday, so it's in favor to us. So they will change the model to remove this leaf and with no structure changes. So which means we don't need to do any changes to our model. And then we the current status is that we pretty much modeled whatever we need to do now. Seems like we are close to complete, so we may request to the last call pretty soon. That's it.
Thank you. Any questions? No. I think then we can move to the next presentation. Tarek, I think it's you.
Hi, my name is Tark, and I'm going to give a quick update on the first three drafts because they were presented earlier in the week, and I'm going to give a detailed, updates on the last draft for the MPLS Yang model. So I'm presenting on behalf of the co-authors listed there. So I'll go over the updates and then I'll close with some next steps. So for the first document that describes the TE model, okay, the summary of the changes we've done there. Basically, let me start with giving credits. We have received comments from multiple reviewers. So thanks to those who reviewed our document, our model, and gave comments. And we continue to work to progress towards completing this model work within the team that we're working on together. The high-level changes we try to align with in terms of the container names and the leaf names with the OC MPLS model. So we're mostly aligned now. We added additional attributes under the tunnel entry. We are using the routing types that are being standardized at IETF. And we added some a path signaling type, which identifies how you're going to signal an LSP. Is it via RSVP or segment routing or maybe statically provisioned? Other than that, we added additional constraints and a small modification in the explicit route output. So in terms of next steps for this draft, we are working together with the authors of the stateless RPC draft. So we reached kind of an agreement this week, so we will continue on that. We request further review, and we will try to address the comments as we get them. The next three drafts, they describe the RZP and RZPTE model. A summary of changes we've done. We have split the document into two now, and we are going to make another split so that the MPLS part will be in a separate document. The RZPTE generic model will be on its own in a document, and the RZP will be in a separate document. So we'll have three documents there. In terms of changes to the model itself, we added some additional attributes in the RZP sessions list, the neighbors list, and a back reference for the RZP session back to the TE LSP that got instantiated. And we integrated with the latest keychain model. Thank you. In terms of next steps, we think the RZP base and extended model is stable enough, and we want to move towards the working group last call. For the rest of the drafts, we do ask for further review from the working group, and we welcome comments. And with this, I'll move to the MPLS model. The summary of changes for this model. We are augmenting the IETF routing model. We're trying to model the additional MPLS attributes for an IP route. So the IETF routing model defined a RIB for V4 and V6 address families. We're adding MPLS augmentation to those. And we looked into modeling as well the MPLS routes, which are non-IP, basically cross-connect. So I'll go over our proposal and would like to hear any feedback from the working group. Before I talk about the proposal, we did meet with IETF routing Yang model, RFC 22, I think, if I'm not mistaken. And we had a discussion. They are in agreement with our proposal. Basically, okay, sorry, I jumped ahead. These are the changes we made to the MPLS-based model in terms of adding label blocks. So we are, it's not so clear from here, but we are defining the global label block and local label block for applications that request that. So that's going to show up. It's going to be configurable, and it's showing up under the MPLS space there. We added this knob for TTL propagate from MPLS to IP or from IP to MPLS. So these were the additional items for the MPLS base. Now, in terms of the augmentation to the RIB model for IP route, so we have for V4 address family, I gave this as an example. So we have a route with next hops, and we are augmenting with remote labels and a local label there somewhere. I can't see anything. I apologize. Yeah, I will not sacrifice that. Yeah, so we are for next hop we are adding the remote labels that will be received from the neighbor, the local label that this node has allocated for this IP prefix, and this is per next hop, and this is the basic simple next hop, and all. Basically, what I'm highlighting here is our MPLS augmentation to the RIB model, and the rest is already standardized. This is what IETF routing model has already defined. So we're adding this augmentation for remote labels, for local labels, as well. We're adding some additional attributes like load share and the index of the path, protecting this primary path. Now, this backup path index is common for MPLS and non-MPLS paths. So we are in discussions with AC and the routing model if this could be done for IP routes as well, and this way we can remove it from here. But basically, this is just an indication of the repair path that is protecting this primary path. So this goes for IP routes. This is an example of IPv4 prefixes where V4 next hops are showing. The V4 address is here showing. For V6 RIB, there will be also MPLS augmentation similar to this one. But for non-IP routes, those are basically cross connects. We are proposing to add an additional RIB address family, so it'll show as a V4, V2, V6. Yeah. So it'll be a new address family for just LFIB entries or labeled routes, and these will not obviously be IP prefixes. An example of those will be per VERF label, per CE label, RZP labels, and so on. So these are non-IP labels that we need to model inside a separate RIB. So that's the approach we're taking with our modeling. We'd like to hear feedback. We think this is suitable, and we did run this by the IETF routing model authors, and they are in sync with us. In terms of next steps, we think with this change, the base model is stable enough. Tentatively ready for working group last call, but we also welcome further review and comments. With this, I think that's it. Thank you. Any questions or comments?
No questions. So if not, I think we can move to the next presentation. And I guess we have to work a bit on placing mics, cameras, and screens. Yongyi. Yeah. Oh, okay.
Hi, as you might have noticed, I'm not Young Lee. I think Young had to head for a plane this morning, so I'm going to take over his slot. Probably means I should have read the slides as well, actually, but maybe it's more exciting this way. So there's, I think, two documents. I hope there's two documents here. The first is the WSON document, the Yang model, and then that leads into FlexiGrid. Oh, can you just adjust? Yeah, thank you. Do not adjust your eyes. Adjust the screen. Yes. So what are the major updates for the WSON document since the last revision? Essentially, clarification of the link attributes, and given the ongoing discussion of comp versus operational state data, we've kind of updated the document in terms of adding the operational state. So you can see sort of the updates there. We have also updated the node attributes in the WSON document as well. So now that's essentially sort of most of the node attributes there. You'd have to look at the diff to see what the differences are. I can't remember. And then again, especially given comments this week, we need to make sure that we're aligned with the T topology model. I'm looking at Groove here. I think the only maybe impact will be the augmenting the paths. Is there anything else? No, that's no, there isn't anything else. Good. Okay, so that's easy. So we can do that in the next revision as well. Ooh, I think that's the last slide for WSON. So any questions for wavelength electric optical networking? Nope. Okay, great. Moving swiftly on. So this is the second document, and kind of interestingly, when we were originally working on WSON, I think we actually had FlexiGrid included, and then we split out the technologies into two models. Maybe Sergio's looking at me slightly strangely, maybe it was vice versa. Anyway, we've got a FlexiGrid document, and the reason I mentioned some of the history is there's been a comment this week that maybe FlexiGrid should just augment WSON. It's a use case of WSON, so that's something else we need to look at as well. Why do we need FlexiGrid? Well, there are variable bitrate transponders being developed, and we need to model them and configure them. We augment the network T model as well as the tunnel T model. That's our media channel in FlexiGrid. And this is just an individual document actually, whereas the WSON document is a working group document. The model that's defined in the document split into two submodels, the traffic engineering database and media channel. I think we have network media channel and media channel as well. What else are we trying to do? So, yes. So one point, I think the most important point on this slide is we're probably going to break this document into two separate documents so we can work on the traffic engineering database independently from the media channel. And then the first document that we'll probably look to adopt is the traffic engineering database model for FlexiGrid. We won't ask to do that now because we haven't sort of broken the document in two yet, but we'll probably get that published very shortly after this IETF and maybe adopt on the list. We don't have to wait for Prague. There's a couple of comments that I probably want to make after various conversations this week. There was some concern about the terminology that we're using in the FlexiGrid document. It seems that we're using terminology that we inherited from some European projects. Gert, did you want me to finish my diatribe? Okay. So yes, we need to kind of just clean up the document, make sure that we're only using sort of ITU definitions, recommendations, application codes, etc. Some other nits that we had this week are, have we actually reviewed the open config transport service model and also open ROADM? So there's a variety of models proposed for the nodes, the service, links across both of these organizations, sort of formal organizations, but let's say efforts. So we just need to kind of reflect maybe some of the discussion or some of the attributes in some of that activity. Probably less so actually with open config, more with open ROADM. That seems to be more applicable. And given the routing area meeting this week, we probably want to do another sort of pass of the document to reflect some operational considerations. Maybe instead of trying to list sort of everything, just try to focus on operational state change.
Okay. Thanks, Josget. So one of the things I want to mention here is that actually there is no, let's say, suitable transponder model yet. So all the application codes we have today are for 10 gig, 2.5, 10. So they're not supposed to support FlexGrid.
Okay, fair enough. Yep.
So an idea would be to kind of separate it out. Otherwise, progress would probably be very slow. So just wanted to bring it up that that kind of needs to be lined.
Okay.
So sorry, your suggestion is to split the 10 gigabit from the rest and use the application codes for 10 gigabit and the modulation formats for the other. Did I get it correctly?
No. So this is about the let's say the line side. So there is, strictly speaking, that it is not necessary to define transponders in the model. So those could be added later.
Okay. But if you want to use the network, you need also the transponders.
Obviously, but I mean, if there is no transponder definition which we could use, so it would slow down the draft, which is useful, just because, well, we need to wait for others to complete their work, so it might be easier to progress by splitting out the transponder, do it for later, and go on with the rest.
Cool. Okay, so thanks. Next presentation. Okay.
This is Dhruv. So I will be presenting the PCEP Yang model. Yeah, so just a recap, this is the Yang model for the PCEP speaker, and it takes care of both the PCC part as well as the PCE part. Of course, it has both the idea of how do we configure a PCEP speaker, PCEP sessions, peers, etc., as well as getting the state, which includes the LSP state as well. So the base is as per 5440, but as you know, in PCEP, we have had various extensions. So the Yang model currently handles all these extensions using the Yang feature concept. And the one big change that we have done is with the statistics. Earlier, the stats were part of the main model itself. So in this update, we have removed stats and put them in an augmented model of the base, so that if you are not interested in implementing those stats, you can do them separately. And otherwise, the size of the model also was increasing quite big. So having this division between IETF PCEP and IETF PCEP states has helped. So that's the main change that we have done in this time. Apart from that, since we are reusing groupings from other models, so of course that has had an impact, and that's something when you try to compare the diff, you would see between the last tree and the current tree. Apart from that, we did a a lot of change, a lot of fixing in the sense that earlier we were only doing P-Yang and other validation. Now there are Yang lint and other validation tools that go in much more depth. So we fixed all those errors that we were getting. We also did one change related to must and when statement, and based on the guideline in various places, actually we were using must when we should have used when. So we made all those changes in the Yang model. Those things you will see only when you see in the Yang model. It may not show in the tree. So another thing was RPC. So far we did not have any RPC, but based on the sync optimization draft, which just recently went to RFC editor queue, we wanted to have a mechanism for an operator to trigger resynchronization for a particular PCEP session. So that RPC has been added in the current model. So this is how basically the stats look. We have stats at the peer level and the stats at the session level. The session level is the stats, what's happening at the current session time, and the peer are the cumulative stats, because as you know, in PCEP session can go up and down, but we wanted to maintain those statistics beyond that. And this is also compatible to our PCEP MIB as well. So that's the main change that you would see in the current document. And this is augmenting the IETF PCEP at two places, peer and session. A good thing is that this is all state. So at least for this module, we don't have to worry about the, the other discussion about any change to revised data store. These are the grouping changes that happened in IETF keychain and IETF TE related to the ERO. In PCEP, the only place we have ERO is the path key, because PC may have to maintain those path key and PC is the owner of that. So that's where we use the grouping to maintain the path that we allocated for a particular path key. Again, only in the state part, this cannot be configured. The first question here was actually I asked earlier at the start itself. So now, based on her answer, among the authors, we need to rediscuss and decide what's the next step. And based on us, we'll then come back to the PC working group and say, what should we do? Right now, the state is that from the start, we had the top model, IETF PCEP and PCEP state. So, but PCEP is an interesting case as well, in the sense that there is a lot of data that is only state. For example, sessions are not configured. Session is a state. LSPDB is a state. Path key information is a state. So we have a lot of things which are not configured. So we can, in fact, model it in a little different way by removing everything that is pure state and maintaining it separately. And the two things that can be both configured or states are the local entity and the peers. Because in PCEP, you can configure a peer or you can discover a peer. If you are discovering a peer, it will show up only in the state. But if you have configured, then it will be in the config part as well. So we authors will relook based on this and come back to the working group with what's the next step with the revised data store part as well. The second question to the working group is, what do we do with notifications? Currently, we have some very simple notifications, which were sort of like, if we read 5440, it says that these operationally mandatory to implement, that you should definitely have session up, down, or overload notification. But we also now have notification subscription and the Yang push mechanism. So this feedback I wanted from the room is, should we let go of all notification blank, or the basic notifications we should still have, which will be mandatory to implement, which you don't have to subscribe to, but you always get. So that's a question that I have. Currently, we have some 4 notifications. Should we let it be there or should we remove? Because if you see the new module in other groups, people are these days not putting any notification at all. So I'm not sure what's the right guideline here. So the feedback from the room regarding this would be useful. So we'll come back to this questions, this last question again, once I tell what's the next step for me. We had one action item pending, which was PCEP-S, that is the TLS support for PCEP. I had a discussion with NetConf authors of IETF TLS client and IETF TLS server. This is a generic TLS groupings that they have, and they are using this inside RESTconf model. So the good thing is they can easily be reused by PCEP, and these groupings are generic. So our next step would be publishing those, integrating and publishing. And you would see that I'm using Adrian's soon. And let's see if we can commit to that. So that's about it. And if anybody has an idea on the notification, will be nice to hear. And any other comments as well.
Thank you. Any questions, comments? No? Or yes? Yes.
Julien Merrick, just to start the discussion, but maybe we'll have to take this to the list. About notification, do you see a reason to do differently from other usual habits in other modules in the routing area? What would trigger something specific to the PCEP module there?
It's not definitely not specific to PCEP module, but I'm not able to find the right guideline there because it were there and they disappeared suddenly. But from everybody's model, but I want to know what's the guideline there. That should be, because this is true for any type of session, RSVP session, OSPF peer session. Should we keep those notifications, or the general guideline is no notifications? Everybody has to subscribe. If they want to know the session state, they should use the Yang push and the subscription model only. I don't know the answer for that. So yeah. Maybe we'll start that discussion or talk to the Yang doctors. Maybe that would be the better.
That could be a way forward. Thanks.
Tariq, yes, I think you answered what I'm going to ask. Is in RSVPTE we are following the subscribe publish type of thing, and of course you could do a classic way of supplying notification, and we don't have clear guidance on which way should we go.
Yeah, so Drew, I think we take that question to the Yang doctors and try and get some guidance. But I mean, I think it's up to us authors to try and do the right thing, basically, whatever the right thing is for the PCEP model. So let's listen to the guidance if there is any. But ultimately, we propose what we think the right thing is to the list and let people review that.
Thank you.
Thank you. The next presenter, please, is Gert.
Hi, this is Gert. Can you hear me? So this is the Yang model for WDM interfaces. I say those are non-standard WDM interfaces. It already has, let's say, a huge set of history, mostly devoted to the fact that we initially tried to, let's say, be close to an existing ITU standard in defining all the parameters. It turned out that that approach didn't find a lot of acceptance. So in the end, we're focusing now on plainly non-standard interfaces. Simply, they're non-standard because there is no standard, not because we would like to deviate from anything that exists. The transponder model is still following the modeling standard. I think you probably saw the kind of structure many times. So let's jump over it. There's also a motivation problem statement out there. So coherent transceivers, I can say everything which is 100G and beyond is not standardized. It doesn't have an application code. So all we did in WSON for defining transceiver are basically not applicable. And we need to find an alternative solution until the standard is available. I mean, you probably saw in the previous discussion that a lot of drafts waiting for a solution of that. So we also have, let's say, several, let's say, combinations of parameters. So
WDM interface is not, let's say, simple to configure. There is about 24 of parameters you probably need to configure in order to make it really work. Another thing is we still aim for interoperability, but we cannot guarantee it. What it means is there are interoperable data plane implementations out there. Those have been defined with some parameter sets, and they're interworking. So there is some precedence, let's say, that by using the same parameter sets, there's a high likelihood that interfaces can interwork. However, there's no formal guarantee or theory behind it. It's simply kind of an industry fact of life. We would like to capture it here. Again, if standard comes around the corner and provides better usage, we'll be happy to cooperate. The idea here is to augment the interface structure in the Young model. So it's not really rocket science what we're doing here. It's really just an augmentation. And to provide a consistent view of how to model the parameters. For those, there's also a new construct being put in, which we call mode. It's a little bit similar to what people know about application code, but it's not the same. So essentially, modern transceivers, they can operate in different modes. So think of it of different modulation schemes or different for error correction. Now, if you add up all the parameters you can choose, it is an almost infinite number of combinations. So operators and also system vendors, they would like to come up with a set that they can really test in the lab to ensure that it's working. So this is what is behind there. So consider those modes to be, let's say, a list of tested combinations of parameters. Now, what the draft does is say, okay, out of that mode, all those modes which have been defined by the system vendor, we pick one, which we declare to be the active one, and run that. Now, during runtime, there are different things. One is to say, okay, I can measure for my data plane what I get, so power, for example, and compare it to the limits which have been defined in that particular mode that have been selected. And of course, the mode is not, let's say, configuring 100%. There are different parameters like wavelengths, which need to be defined anyway, so it's not part of that mode template. It's a kind of additional parameter that need to be defined. So with this kind of mechanism, what we want to achieve is a kind of operational simplicity, rather than having an operator selecting between, say, 50 different parameters and figuring out how to combine them. There are those predefined modes, pre-tested modes that can simply be selected and put in operation. I give you here a snippet of what those modes contain. So, for example, number one is the mode definition. So it defines the minimum, maximum parameters. So, for example, what is the minimum or maximum output power I would expect. So later on it can be tested against. Then obviously the actual parameters are those that have been selected. So it has, for example, a particular fault error correction combination with modulation. Then we have on the bottom the configuration parameters, typically wavelengths, where we want to move the wavelength, and we have the threshold crossing or supervision parameters. They can say, okay, now if my actual measurement exceeds the thresholds which have been given in templates, I will write a notification to the controller. So status again has a lot of history. It's an extension to the IETF interface. No magic here. The Young module is also in line with with another draft, which is impairment validation. So the impairment validation draft is a companion document of this one, which really deals with the line side only. So we kind of separated out transponders in one draft and impairment validation in another. But I would say they're better read together. It's because of technical reasons, as I said, the transceivers are not yet standard, so we were suggested not to go for standard track. So that's an experimental draft. Obviously, impairment validation is different. Since there are no transceiver in, but could go standard track as well. Third point is we dropped any intention to align with standards here officially. So if you have concerns that other standards organizations are not ready yet, that doesn't apply to this draft. We are not talking about those. And there are a few changes, mainly typos, and we added the threshold crossing notifications. Also, that was something we were previously asked not to do. We introduced the boundary conditions, and we also introduced the notion of potential electron modes to simplify the provisioning and operation of those modules. Question? Okay. Thank you.
Okay, and our final presenter is Kun.
Hello, good morning, everyone. This slide, I will talk about two drafts about OTN topology and OTN tunnel. And the OTN topology draft actually is augment the T topology model. And this draft defines a YARN data model to describe the topology of an OTN, which is dependent of control plane protocols. And this draft between the 06 and 05 version, we only update the YARN model version from 1 to 1.1.1 for future compliance, such as for the schema mounts, which is defined in the YARN version 1.1. And this so far we have addressed all the comments, and no more comments need to be addressed. So because this draft is pretty stable, so we ask for the WG adoption. Any comments?
I'm going to wake up two people randomically, Dan and Italo. So I see a tight connection between this draft and the work of the transport and BI design team. Did you plan some sort of integration, interaction whatsoever?
Yes, we discussed a bit about what to do with the technology-specific augmentation, and we can use this draft for the technology in the analysis, so we can analyze the use cases using this draft for the technology-specific. And I don't know, I like let you decide whether you want this to progress as working group drafts or the design team to take them on board and progress it.
Well, actually, I see two options. The first one is to proceed this draft independently and then be referenced by the design team for the use cases that you are working on, or include it into the work of the design team, focus on the use cases that you're working on, and then possibly extend with the support for other stuff. This is up to you.
Yes. Okay. I'm open. I don't have a strong opinion between the two options.
Hi, Daniel King. Yep, so I think we just have a quick chat with the transport design team members, but I think my favorite option too, I think at this stage, but we'll confirm that on the list and report back to the work group. Okay, thanks.
Okay, next draft is the OTN tunnel model, and this draft is augment the T tunnel model, and actually it replaced the older draft of the old OTN service model. Now the OTN service model will not be updated anymore. And this OTN tunnel model defines the OTN tunnel yarn, and also it provides the standard transport types based on the G.709. And this version will also update the yarn version, and certainly will pass the examination use the P-yarn. And we also make some terminology description and change some terms. And we also add add some concept about the OTN tunnel, which is the book-ended and or the non-book-ended, defined and network side. That's next step we will because we add these two concepts as new, so we really look forward to any more comments about these two concepts. Any questions?
Any questions? Okay, I have a similar comment to the previous one. Actually, during the SICAM session, we were requested what was the relationship between the transport and MBI work and ACTN. Basically, the transport MBI work aims at being the technology-specific extensions of the ACTN interfaces. The ACTN MPI mandates to use T topology, T tunnel, path computation API as the minimal set of features to be supported. Those are the technology agnostic, let me say, components of the ACTN interfaces. I see this work and the transport MBI work as the technology-specific extensions to the ACTN interfaces. And this is more true due to the fact that this work extends the T tunnel and the T topology. So I would like to make this clear and possibly have this work, let me say, progress in this way. I'm done.
Lou Berger, I just wanted to clarify the comment that I made in a very inarticulate way in CCAM. The point I realized I was really trying to make in the analysis document is that the analysis was assuming that there was a certain decision, a certain way to implement the ACTN interfaces that that haven't yet been defined. And so it's just getting ahead of itself a little bit. And while we think we know the direction the ACTN interfaces are going to go, we haven't agreed on those. And just to be sensitive to that.
Mm-hmm. Okay.
You know, so the analysis of a solution that's not yet defined should say that this is assuming certain things rather than saying this is that interface looks like. And that's really the crux of what I was getting at. And I agree, I say it in a very good way. That doesn't diminish your last point where this is a good foundation for some work in this area.
Thanks.
Okay, thanks. I think that was the last presentation.
Just
there's one comment. Okay.
Yes, I think that we can discuss whether this draft goes into the design team or not. I think anyway, the analysis can use this document and then independently on what is the outcome of the decision. We can use this document as an input when we go the analysis. So we don't block the analysis from the decision. Thank you.
Okay, thanks. I think now it was the last presentation. Thank you very much. Blue sheets. So if you have not signed the blue sheets, they are here on the first table. And that's for the IETF meeting, at least for us, in Chicago. Safe travels, and I guess see you in Prague in summer.
Let's not get.
Yes. Yeah, in time.
For you, maybe.
Still to check out.
No, we have 1 hour.
Yeah, 12. Yeah. Yeah, me too. That was.
When we run over 7.
Oh, it was also my concern. I think it was just because you never know. And I think the last presenters are very fast. Yeah, they had like 7 minutes instead of.
Well, one stage was funny.
Yeah, exactly. Yeah.
And it was
Yeah, that was also a bit my worry that the first discussion is already twice as long as planned. So you're also flying back today?
Yes.
Okay.
Frankfurt.
Yeah. Oh, me too. So
You too?
I guess we're on the same flight then. At 4 p.m. for 5 or something.
For 5, yes.
Yeah.
It's planned. Half Europe is there.
I think so.
Italo is there, Seth is there.